In this video, we are going to talk about how to integrate functions that leads to inverse trigonometric functions. Okay, let me first present to you the alternate notations of inverse trigonometric functions, for we will be using this in the entire duration of this video and also in our class. So firstly, the inverse sine of u is arc sine u. The inverse cosine of u can be written as arc cosine of u. The inverse tangent of u can be written as arc tangent u, and so on. Now there are three formulas that you need to know. The first one is the integral of du over the square root of a squared minus u squared is equal to arc sine u over a plus c. And the second one is the integral of du over a squared plus u squared is equal to 1 over a arctangent u over a plus c. And the last one is the integral of du over u times the square root of u squared minus a squared is equal to 1 over a arcsecant u over a plus c. Now please take note of these formulas, for we will be using this in solving the following problems. Now let's have the first one. Integral of dx over the square root of 4 minus x squared. So as you noticed, this is of the form square root of a squared minus u squared. So where u squared is equal to x squared, and get the square root both sides. So we have u equal to x. Get the derivative, so we have du equal to dx. And we have a squared equal to 4. Get the square root of both sides. We have a equal to 2. And going back to the given problem, we replace dx by du and 4 by a squared and x squared by u squared. So as you can see, we have the formula of arcsine. So this is now equal to arcsine of u over a plus c. Now we can do substitution. So arcsine of u, which is x, so you put x, and a here is equal to 2, so you put 2, and add c. So this is now our final answer to the problem, the integral of dx over square root of 4 minus x squared. Okay, let's have another problem. So find the integral of 5 times dx over 49 plus x squared. So again, you can see that the denominator is of the form a squared plus u squared. So we put u squared equal to x squared. Get the square root of both sides of the equation. So we have u equal to x. Get the derivative. So we have du equal to dx. And clearly, you can say that a squared is equal to 49. Take the square root of both sides. So we have a equal to 7. Now we replace given problem by, first we put 5 in front of the integral symbol. So we have dx be replaced by du, and 49 is equal to a squared. So we put a squared plus u squared. So again, a very familiar formula, which is for arctan. So now we put 5 times the formula for arctan is 1 over a arctangent u over a plus c. Now we plug in the original values. 5 over 7 arc tangent of u, which is x over 7 plus c. So this is now the answer to the given integral. Okay, so now let's go to the next problem. So find the integral of 4dx over x times the square root of 9x squared minus 1. So in a familiar form, we can put u squared equal to 9x squared. Then get the square root of both sides. So we have u equal to 3x. And then differentiate both sides. So we have du equal to 3dx. And for the constant, we have a squared equal to 1. Get the square root of both sides. So we have a equal to 1. Okay, so now we will solve for dx for our substitution later. So we have dx equal to du over 3, and that is achieved by dividing both sides to 3. And then we can also put here or solve for x, which is u over 3 if we divide both sides by 3. Okay, so now plugging in those values. So we put first 4 in front of the integral symbol and then replace dx by du over 3 over, we have u over 3 for x times the square root of, so 9x squared is equal to u squared, and then 1 is equal to a squared. So basically we have substituted those that we did earlier. So we have now u as a variable and a as the constant. So what we just did is we cancelled 1/3. 4 times the integral of du over u times the square root of u squared minus a squared. So this is a familiar form leading to arc secant. So we write now 4 times 1 over a arc secant u over a plus c. You plug in first the original values. So 4 divided by a, where a is equal to 1. So 4 divided by 1 is equal to 4. So we just have to write 4. Arc secant u is equal to 3x over a, which is equal to 1. So 3x divided by 1 is still 3x. So I just put 3x and then plus c. So that's the final answer to the given integral. Now we go to the next problem. So find the integral of x dx over square root of 1 minus x raised to 4. Okay, looking at the denominator, we can say that it is of the form a squared minus u squared. So it's inside the square root symbol, where we can say, or we can write here, a squared is equal to 1. Take the square root of both sides, you have a is equal to 1, and you have u squared equal to x raised to 4. Take the square root of both sides, we have u equal to x raised to 2. Then get the derivative, we have du equal to 2x dx. Now solving for dx, we divide both sides by 2x. So we have du over 2x equal to dx. Now we are ready to plug in what we just did. So we have the integral of, so we have it solved for x, so just write x, replace dx by du over 2x divided by the square root of a squared minus x raised to 4 is equal to u squared. Okay, so we just cancelled x in the numerator. Now we have 1/2. We put it in front of the integral symbol since it's a constant, and then rewriting the given integrand, we have du over square root of a squared minus u squared, and it actually is leading to an inverse trigo function, which is arcsine. Okay, so just recall the formula. So we copy first 1/2, and then we put arcsine of u over a. So in this case, we now plug in the values, which is x squared over 1. So we need not write 1 there. Okay, so for our final answer, we have 1/2 arcsine of x squared, okay, plus c. So that's it for this problem. Easy peasy. Okay. Now you move on to the next problem. Okay, so find the integral of x dx over x raised to 4 plus 81. So notice that the denominator is of the form, yes, u squared plus a squared. So again, u represents the variable and a as the constant. So we can actually interchange them, so it doesn't matter. It still leads to the arctangent formula. Okay, so we will erase this first, and we start doing what we just did earlier, just like what we did. So we put u squared here equal to x raised to 4, and then get the square root of both sides. We have u equal to x squared, and differentiate both sides. We have du equal to 2x dx. Okay, so we can actually solve for dx by dividing both sides to 2x. It's giving us du over 2x equal to dx. On the other hand, our a squared is equal to 81 since it's a constant, and then get the square root, we have a equal to 9. Now we do the substitution. So the integral of x, we copy dx is equal to du over 2x and then divide by x raised to 4 is u squared plus 81 is represented by a squared. Okay, so in the numerator we can cancel x there. So it is now equal to 1/2. We put the constant in front of the integral symbol. So 1/2 integral of du over u squared plus a squared, or we can interchange them, a squared plus u squared. It's just the same. So this form actually leads to arctangent. Okay, so now our answer is 1/2 times 1 over a arctangent of u over a plus c. So our final answer, so we should replace a by its original value and u by its original variable. So we have 1/2 times 1 over 9 arctangent of u is equal to x squared, okay, over 9 plus c. Okay, so that's it. We have to finalize. So we multiply 1/2 and 1/9. So we have 1 over 18 times the arctangent. We just copy. Okay, arctangent x squared over 9 plus c. So that is our final answer for this problem. Okay, so if you have any questions, just comment down below or send me a message via my page, Teacher Phil. Okay, so now let's go to another problem. Dx over square root of x to the 4th minus 16x squared. So take a look at the given denominator. So you can see that there's a common factor there. So rewriting the given denominator, isolating it from the integrand, we factor out x squared. So we have x squared minus 16, and having factored out inside the radical sign, we now take the square root, which leads us to x times square root of x squared minus 16. So, and this is of the form u square root of u squared minus a squared, leading us to arcsecant. Okay, so now we rewrite the given problem using the factored one. So we have dx over x squared of x squared minus 16. Now we let here u squared equal to x squared, get the square root, so we have u equal to x, du is equal to dx, and you have also a squared equal to 16, get the square root of both sides, you have a equal to 4. So now we're ready to plug in and substitute here. So you have the integral of du for dx, x is u, and square root of u squared minus a squared, replacing x squared and 16. And this gives us 1 over a arcsecant u over a plus c. So that's it. We now replace a by 4 and u by x. So giving us the final answer, which is 1/4 arcsecant x raised to x over 4 plus c. So that's it. Now it's time for you to solve the following exercises. So feel free to pause this video and start solving number 1. Okay, now ready to solve number 1. So that is integral of dx over x squared plus 4x plus 5. So what we'll do here is we do completing the squares. Okay, so in here we have isolated the polynomial x squared plus 4x plus 5 to show to you the process of completing the squares. So you may recall this or check your textbooks and other reviewers for this process. So basically I'm doing now the completing the squares. Okay, so the first polynomial in the first term, so you can factor that, giving us x plus 2 raised to 2 plus 1. Okay, so that is actually of the form, as you noticed, u squared plus a squared, giving us the idea that if we integrate that kind of integrand, will give us arctangent. Okay, so we now rewrite our integrand using the result of the completing the squares. So you have dx over x plus 2 squared plus 1. Now we put u squared equal to x plus 2 squared, so the one with the variable. Okay, and then get the square root of both sides. We have u equal to x plus 2. And our a squared is equal to, a squared is equal to 1. Get the square root of both sides. We have a equal to 1. Now we differentiate u here, so du is equal to dx plus 0. Okay, so we now do the substitution. So we have du over x plus 2 squared will be replaced by u squared plus a squared. So simply leads us to arctangent. Okay, so we have 1 over a arctangent u over a plus c. And then plug in the original variables. So that's it. We have 1 over 1, which is still 1. So we need that to put 1 there. So we have arctangent of our u is equal to x plus 2. So we put x plus 2 over 1. So you need not write 1 there, so plus c. This is the final answer to this kind of problem. So imagine we did completing the squares to be able to determine the final answer. So we now have the next problem, or next exercise. Find the integral of dx over the square root of 8 plus 6x minus x squared. So if you notice, that polynomial can be simplified in a form that we are familiar, leading to arcsine, right? So for us to be able to do the completing the squares, we arrange the polynomial by factoring out negatives. So we have x squared minus 6x minus 8. So we can isolate this polynomial, so we can do the completing the squares. Okay, so fast forward. Now we have the result of the completing the squares. So we rewrite dx over the integral of dx over square root of. So we put negative sign times the quantity x minus 3. If you factor that, squared minus 17. Now you notice that you have the negative sign there, so you distribute the negative sign inside the parenthesis and then rewrite the given integrand, and that's dx over the square root of, so negative times negative 17, we have positive 17, you put that first, minus x minus 3 raised to 2. Okay, so we can now assign the variables and constants inside the radical sign. So you have a squared minus u squared format leading to arc sine. So your a squared is equal to 17. So to get the value of a, so get the square root of both sides. If you have a equal to square root of 17, and u squared is equal to x minus 3 squared. So get the square root of both sides. You have u equal to x minus 3. And then differentiate to get the dx. So you have du equal to dx minus 0. Okay. So we now plug in or do substitution. Erase this first to give way to our continuation of the solution. So how are you? Do you still follow? So this is actually found in your book, so I just selected this to be part of the exercise. So we have the integral of dx over square root of 17 minus x minus 3 squared. So I have just rewritten and then do substitution. So dx is equal to du over the square root of, so we put a squared equal to 17 and then x minus 3 squared equal to u squared. So right, it's familiar, leading to arc sine. Thus we have arc sine of u over a plus c. So that's the formula actually. So now we plug in the original values. So u being equal to x minus 3 and a equal to square root of 17. Therefore, the final answer is arc sine of x minus 3 over a is equal to square root of 17. So that's it. Don't forget to write plus c. So we now have the final answer to the given problem. Okay, so and the last exercise. So again, this can also be found in your book, one of the examples in your book. So you have the integral of dx over x times the square root of x minus 1. And it kind of looks similar to the formula leading to arcsecant. Okay, but inside the squared symbol, it's not squared. So it's just x minus 1. We will try. Okay, so you put u squared equal to x. So we get the square root of both sides. So we have u equal to square root of x. And for our a squared, we have 1. Get the square root of both sides. We have a equal to 1. So going back to u, we will differentiate. So du is equal to 1/2 x raised to -1/2. So that's the power formula. So times dx. And now we rewrite. So we have 1 over 2 square root of x times dx. Alright, so now we solve for dx. So we multiply both sides by 2 square root of x for us to be able to solve for dx. Thus we have 2 square root of x times du equal to dx. Okay, now we do substitution. So the integral of dx is equal to 2 square root of x times du over, okay, so take a look at what we just did. So we have x equal to u squared. So you put the value of x, which is u squared, times the square root of u squared minus minus 1. I mean It's a squared. Okay, and take a look at square root of x in the numerator, so it's actually equal to u. And we can cancel that u, so we can cancel one of the u's in the denominator. So if we rewrite now, okay, putting 2 in front of the integral symbol, so we have du over u square root of u squared minus a squared. Voila! It's actually arc secant, so the formula is 1 over a arc secant u over a plus c. And then we bring back the original values of a and u. Okay, so we forgot the 2 there, so you put 2 before the arc secant. Now 2 times, since a is equal to 1, so 2 times 1 over 1 is still 2. And then you copy arc secant of u, which is square root of x, divided by a, which is equal to 1, so you need not write 1 there, plus c. And that's the final answer for this problem. Okay, so we just did it. Now it's your time to solve. So please take out your books and answer problem set number 8. Okay, and upload your solutions via Moodle or the M-Rooms.